As the keel settles into the jig, hydraulic clamps lock simultaneously. Laser lines sweep the structure, confirming
Passive composite skins are moved into place by robotic gantries, positioned with sub-millimeter accuracy before the automated drilling process begins.
The automated orbital drilling robot drills, countersinks, and cleans each hole in a single high-speed pass.
The cockpit tub is precisely lowered into the fuselage. Laser-guided tools assist the team in achieving perfect alignment before the final seating.
Okay, bringing it forward now. Watch the alignment.
Looks good. Locking sequence initiated. Confirmed seated.
As the radome locks into place, a technician uses a feeler gauge along the seam, confirming the zero-gap fit essential for stealth capabilities. In the assembly hall, robotic systems apply the high-strength adhesive with pinpoint accuracy. The wing spar is then The twin vertical fins feature a titanium and carbon fiber lattice structure. Here, technicians install the
inclinometer reading is showing 0.05 degrees.
Confirming specification match. We are good to proceed. This is the integrated processor bay, the brain of the jet. As technicians install the liquid-cooled racks, once aligned, a localized electric arc instantly melts and fuses the glass fibers. A protective heat shrink sleeve is then applied over the splice. Utilizing advanced ceramic matrix composites, stealthy 2D thrust vectoring nozzles are fabricated with jagged edges for radar invisibility.
Hold it right there.
Millimeter adjustment on the starboard side.
Pins aligned, ready to lock.
Shaping these intake ducts is critical. We're looking for a perfectly aerodynamic surface to minimize radar signature. The rapid opening doors deploy missiles at supersonic speeds. Note the high-strength steel hinges as the mechanical latches engage with a solid click.
Test cycle initiated. Extension sequence nominal. Affirmative. Retracting to lock position.
Cooling lines check green.
A hydraulic ram drives the titanium pin into the structure. Once secured, the jet is lowered slightly to test the initial weight on wheels.
The nose gear, which includes the steering actuators and landing lights, is installed. The steering system is connected to the pilot's rudder pedals via the fly-by-wire computer.
The PDUs, which manage the thousands of watts of power generated by the engines, are installed. These units are
Applying the conductive seal around the sensor aperture requires absolute precision to maintain the stealth profile.
Every component, from the firing pins to the ripcord activation, must be checked. This is the ultimate redundancy safety system.
Reading 0.0 on the forward port side.
Confirmed. Aft starboard reading is stable at 0.0.
Adjusting the geometry here should reduce the reflection significantly.
The signature is normalizing across the fuselage. That's a successful optimization.
Using ionized air, the specialized composites are cleared of static and dust, preparing the surface for the radar-absorbent coating.
First, the stealth putty fills the seams. Then, an orbital sander blends it perfectly flush, creating a seamless aerodynamic surface. A specialized infrared coating is applied to the nozzle, significantly reducing the heat signature against the cold sky.
The probe tests the ram's conductivity. As the digital meter shows, the ohms per square value confirms the coating is within specification.
Overhead panel checks complete. Luminance levels are nominal.
Confirmed. Displays are stable and within NVG parameters.
This is the final integration bay, where the F-22 will receive its mission systems and fuel load before its maiden flight.
The auxiliary power unit provides the electrical and hydraulic power needed to start the main engines.
While the engines are at idle, the pilot moves the nozzles through their full range of motion, up and down. This allows the jet to perform
The jet's laser gyroscopes are aligned with the Earth's rotation. This allows the jet to navigate with extreme precision, even if GPS is unavailable.
Avionics bay temperature stabilizing at 40 degrees.
Copy that. Maintaining max flow for 5 more minutes.
We need to monitor the hydraulic pressure during the high G maneuvers in Sector 3.
Heart rate and oxygen saturation are green across the board.
Harness secure, life support connected.
Roger that. Controls free and clear.